So we went with the McKibben actuator design, inspired by this one made by this guy. It starts off with woven sleeves and a long balloon. Put them together and BAM! You get one PAM, pneumatic artificial muscle. Actually make it two, and stick both ends to plastic boards with holes or tube. When one of the balloon of either side radially expands from air pressure, that side contracts, while the other McKibben actuator remains the same, which causes a bending motion on that side. Theoretically, that is. There is this problem when one McKibben contracts, the other one just buckles and compresses linearly inwards as well, which negates any bending. And this is where the spring comes in. The stiffness of the spring acts as a balance, where when one McKibben contracts, it keeps the other from collapsing in and only bends sideways while straight. Also, it gives an outwards restoring force to return the robot into full-length state, ready for repeated compression and forward movements, which makes it bend quite well. To move forward, we add a silicone stopper at the back and a balloon at the front. Then it goes like this. The front balloon inflates, exerting friction with the walls of the tubes, holding the front like an anchor. Then, the McKibben inflates and contracts, dragging the silicone to the front. When the front balloon deflates, removing the front friction, and the McKibben deflates and returns to the original shape thanks to a spring, the friction of the silicone prevents backward slipping and pushes the overall robot forward from the spring's restoration force. And the cycle repeats, and the robot slowly but surely inches forward. Combine the bending motion of left and right with the forward movement, and we should be able to clear checkpoint 1 and 2. But once we reach the end, how do we grab the ball? Well, we could use a simple suction cup to vacuum the ball in, and that will work pretty well. But what if the ball was a little further out? The suction cup won't be able to reach it. The robot can't leave because we need the friction of the tube to move the ball. So we came up with this other design using EcoFlex and pen molds, along with a front guard to hold it, and with pouches to lift it. This works just like a cowboy lasso. First, these pouches inflate, raising it up. Then the gripper inflates to expand both radially and linearly, which, when its ends are put together like a bratwurst, creates this big curvature that, when the pouches deflate, grabs anything within the big hole, even those far from the entrance, and tightens around like a lasso and grabs quite firmly. Now to show you the coding and wiring of the air pump, it looks like this. Like this. Like this. Here are some improvements to it. Now we've come to the end, so sit back, relax, enjoy the music as you observe the robot's final performance.